A coin C of mass 0.0050 kilograms is placed on a horizontal disc at a distance of 0.14 meters from the center, as shown above. The disc rotates at a constant rate in a counterclockwise direction, as seen from above. The coin does not slip, and the time it takes for the coin to make a complete revolution is 1.5 seconds. A bit. The figure below shows the disc and coin as viewed from above. Draw and label vectors on the figure below to show the instantaneous acceleration and linear velocity vectors for the coin when it is at the position shown. B bit. Determine the linear speed of the coin. C bit. The rate of rotation of the disk is gradually increased. The coefficient of static friction between the coin and the disk is 0.50. Determine the linear speed of the coin when it just begins to slip. D bit. If the experiment in part C were repeated with a second identical coin glued to the top of the first coin, how would this affect the answer to part C? Explain your reasoning. This problem is based on uniform circular motion. Here, a coin is placed on a horizontal disc and which is rotating in counterclockwise direction. And the time period is 1.5 seconds. And then the coin is placed at a distance of 0.14 meters from the center of the disc. That means the radius is equal to 0.14. And then the time period is 1.5 seconds. Here he is in the first bit, he is asking us to draw the vectors, velocity, linear velocity vector and acceleration vector. Here the linear velocity will be tangential to the circular path. So it is making the circular path like this. Therefore, the velocity will be in this direction. So this is the tangent to the circle. So this is the direction. So acceleration is always towards the center. So this is the acceleration. Now we have to find out the speed of the coin. Speed v is equal to 2 pi r by t. Plug in the values, you will get the answer. The answer is 0.6 meters per second. Next bit. Here he is asking what is the linear speed of the coin when it just begin to slip. When it just begin to slip, when the static friction is less than or equal to centripetal force. Okay. So static friction is equal to centripetal force. So therefore, what is the static friction? Static friction is equal to, we know, no? Friction is equal to mu Fn. So what is Fn? Fn is equal to Fg. Because on the coin, sigma F, we will write the force equation. Sigma F is equal to Fn minus Fg is equal to 0. Therefore, Fn is equal to Fg. We know Fg is equal to mg. Therefore, Fn is equal to mg. And we know F friction is equal to mu s Fn. We substitute Fn is equal to mg. We get F friction is equal to mu s mg. Therefore, mu s mg is equal to mv square over r. Rv is equal to square root of mu s rg. Plug in the values, you will get the answer v as 0.83 meters per second. Next bit. He is saying that in the next experiment, another coin of an identical coin is glued to the first coin and then repeated the experiment. And whether he is asking, will the value of p changes? No, it will not change. Why? Because the equation does not contain m. See here, velocity is equal to square root of mu s rg, where mu s is the coefficient of static friction and r is the distance of the coin from the center, and then g is the acceleration due to gravity. So in this, mass is not there. Therefore, whatever may be the mass of the coin, it will not affect the speed of the coin. This is the answer for this question. Thank you. Bye-bye.